Hello viewers, welcome to the channel Amazing Civil Engineering Studies. In today's video we are going to discuss about fluid properties and flow characteristics. Define fluid. A fluid, or liquid, which is capable of flowing. It has no own shape, but conforms to the shape of the containing vessels. A fluid is a substance that continually deforms under an applied shear stress. Liquids are like water, milk, air, steam. Matter exists in two states, solids and the fluids. Fluid state being commonly divided into liquid and gaseous states. Differences between solids and fluids. A solid is generally own shape and change in volume under pure compressive load. It resistance to change in shape without a change in volume under the application of tangential forces. The spacing and latitude of motion of molecules are very small in solids, large in a liquid and extremely large in gas. The intermolecular bonds are very strong in solids, weak in liquids and very weak in gases. Solids are very compact and rigid. Solids materials are steel, wood, plastic etc. Gases, solids, and liquids. Rigid fixed char. Fixed volume. Cannot be squashed. Not rigid, no fixed sheage, fixed volume. 0. Not rigid, no fixed sheage, no fixed volume. Fluid mechanics. Fluid mechanics is that branch of science which deals with the behavior of fluids. Liquids or gases, at rest as well as in motion. This branch of science deals with the static, kinematics and dynamic aspects of fluids. The study of fluids at rest is called fluid statics. The study of fluids in motion, where pressure forces are not considered, is called fluid kinematics. The pressure forces are also considered for the fluids in motion. That branch of science is called fluid dynamics. Units and dimensions. The word dimensions are used to describe basic concepts like mass, length, time, temperature, and force. Units are the means of expressing the value of the dimension quantitatively or numerically. All physical quantities are measured by units. There are two types of units. Fundamental units. Derived units. Fundamental units. All physical quantities are expressed the following. Length, L. Mass, m. Time, t. Derived units. Derived units are expressed in terms of fundamental units. This are area, velocity, pressure etc. System of units. CGS units. The fundamental units of length, mass, and time are taken as centimeter, gram and second respectively. FPS units. The fundamental units of length, mass, and time are taken as feet, pound and second respectively. MKS units. In this system, the fundamental units of length, mass, and time are taken as meter, kilogram, and seconds respectively. The MKS units are called as gravitational units or engineer's units. SI units. This system has 6 basic units, 2 supplementary units and 27 derived units. Basically, the fluids are classified into 5 types, and these are: 1. Ideal fluid. 2. Real fluid. 3. Newtonian fluid. 4. Non-Newtonian fluid, and 5. Ideal plastic fluid. Ideal fluid. A fluid which is incompressed and have no viscosity falls in the category of ideal fluid. Ideal fluid is not found in actual practice, but it is an imaginary fluid because all the fluid that exist in the environment have some viscosity. There is no ideal fluid in reality. Real fluid. A fluid which has at least some viscosity is called real fluid. Actually, all the fluids existing or present in the environment are called real fluids. Newtonian fluid. If a real fluid obeys Newton's law of viscosity, I.e. the shear stress is directly proportional to the shear strain, the need is known as the Newtonian fluid. Example: water, kerosene. Non-Newtonian fluid. If real fluid does not obey the Newton's law of viscosity, then it is called non-Newtonian fluid. Example: paint, toothpaste. Ideal plastic fluid. A fluid having the value of shear stress more than the yield value, and shear stress is proportional to the shear strain, velocity gradient, is known as ideal plastic fluid. Properties of fluids. Density, or mass density. Density or mass density of a fluid is defined as the ratio of the mass of a fluid to its volume. Thus, mass per unit volume of a fluid is called density. Equals mass of fluid volume of fluid. Its units kgm3. Temperature increase with density decrease. Pressure increase with density increase. To estimate the density from characteristic gas equation of PV equals mRT. R equals 287 J/kg/K, or 0.287 kJ/kg. Water equals 1000 kgm3, mercury equals 13600 kgm3, air equals 1.23 kgm3. Paraffin oil equals 800 kg M3. At pressure equals 1.013 N/M2, and temperature equals 288.15 K. Specific weight or weight density W. Specific weight or weight density of a fluid is the ratio between the weight of a fluid to its volume. The weight per unit volume of a fluid is called specific weight or weight density. It varies from place to place because of acceleration due to gravity changing from place to place. Specific weight, W equals weight of fluid volume of fluid W equals G. W equals W/V equals mg/V equals G. Its units, N/M3. Temperature increase with specific weight decrease. Pressure increase with specific weight increase. Water equals 9810 N/M3. Mercury equals 132,943 N/M3. Air equals 12.07 N/M3. Paraffin oil equals 7851 N/M3. Specific volume V. Specific volume of a fluid is defined as the volume of a fluid occupied by a unit mass or volume per unit mass of a fluid. V equals volume fluid mass of fluid. Equals 1/. Its units, M3/kg. Specific gravity, or relative density S. Specific gravity is defined as the ratio of the density of a fluid to density of a standard fluid. S equals density of a fluid, density of a standard fluid. Specific gravity of mercury is 13.6. Viscosity. Viscosity is the property of a fluid, due to cohesion and interaction between molecules, which offers resistance to shear deformation. Different fluids deform at different rates under the same shear stress. Fluid with a high viscosity such as syrup deforms more slowly than fluid with a low viscosity such as water. Shear stress. Viscosity is defined as the property of a fluid which offers resistance to the movement of one layer of fluid over adjacent layer of the fluid. When two layers of a fluid, a distance dy apart, move one over the other at different velocities, say u and u and do. The viscosity together with relative velocity causes a shear stress acting between the fluid layers. The top layer causes a shear stress on the adjacent lower layer while the lower layer causes a shear stress on the adjacent top layer. This shear stress is proportional to the rate of change of velocity with respect to y. Dynamic viscosity. It's defined as the shear stress, T, required causing unit rate of shear deformation, do dy. Its units, Ns/m2 equals T do/dy, or kg/ms, or poise. Kinematic viscosity. It's defined as the ratio of dynamic viscosity to mass density. Its units, m2/s, or Stoke. Vapor pressure. H 2O G. Molecules. Water vapor. H 2O L. Molecules. Vaporization. A change from the liquid state to the gaseous state is known as vaporization. Vapor pressure. The liquid is kept in closed vessel. The vaporization take place, the molecules escapes from the free surface of the liquid. This vapor molecules occupies the space BW free liquid surface in the top of the vessel. These accumulated vapors exert a pressure on the liquid surface. This pressure is called the vapor pressure of the liquid. Water vapor pressure is 2337 N/m2 at 200 C, but 101325 N/m2 at 1000 C. Surface tension. Surface tension is defined as the tensile force acting on the surface of a liquid in contact with a gas or on the surface between two immiscible liquids such that the contact surface behaves like a membrane under tension. Due to molecules' attraction, liquids have properties of cohesion and adhesion. Cohesion is due to the force of attraction Bw molecular of same liquid. This force is very small. Adhesion is due to the force of attraction Bw the molecules of two different liquid. The molecules of the liquid and molecules of solid surface. Bulk modulus. It defined as the ratio of change in pressure to the rate of change of volume, is called as bulk modulus of the material. Bulk modulus, K, equals change in pressure, volumetric strain. K equals dash dP slash dV slash V. Volumetric strain is the change in volume divided by the original volume. dV slash V. Negative sign for dV indicates the volume decreases as pressure increases. K equals dP slash d slash dV slash V equals d slash. Typical values of bulk modulus. K equals 2.05 x 109 N/m2 for water. K equals 1.62 x 109 N/m2 for oil. Compressibility. The compressibility of a fluid is the reduction of the volume of the fluid due to an external pressure acting on it. A compressible fluid will reduce, or change in volume in the presence of external pressure. Compressibility is reciprocal of the bulk modulus of elasticity, which is defined as the ratio of compressive stress to volumetric strain. Compressibility. Compressibility is given by equals 1/k. Its unit in N/m2. In nature all the fluids are compressible. Gases are highly compressible but liquids are not highly compressible. Relationship BW bulk modulus, K, and pressure, P, for Agas. The relationship BW bulk modulus of elasticity, K, and pressure for a gas for two different processes of compression are as isothermal process, isentropic, or adiabatic process. Capillarity. Capillarity is defined as a phenomenon of rise or fall of a liquid surface relative to the adjacent general level of liquid in a small tube, when the tube is held vertically in the liquid. Capillarity occurs because of intermolecular forces BW the liquid and surrounding solid surface, and due to pressure of cohesion and adhesion which cause the liquid work against gravity. It is expressed in terms of cm or mole liquid. Its value depends upon the specific weight of the liquid, diameter of the tube and surface tension of the liquid. Capillary rise. If the glass tube is inserted vertically in a liquid, say water, the liquid will rise in the tube above the level of the liquid surface is known as capillary rise. S equals surface tension of liquid equals on leaf contact BW liquid and glass tube. Weight of liquid of height h in the tube equals area of tube xh, x, xg equals p/4x d2xh, x, xg, I. Vertical component of the surface tensile force equals Sx circumference, x cos equals Sx pd x cos 2. Equating equation, I, and 2. P/4x d2xh, x, xg equals Sx pd x cos h equals Sx pd x cos P/4x d2, x, xg h equals 4s cos xg/xd. Capillary depression. If the glass tube is dipped vertically in a liquid, say mercury, the level of mercury in the tube will be lower than the general level of the outside liquid. Two forces are acting on the mercury inside the tube. First one is due to surface tension acting in the downward direction and equal to Sx dx cos I. Second force is due to hydrostatic force acting upward and is equal to intensity of pressure at depth hx area. Equals px, p/4x d2, equals gxhx, p/4x d2, 2. Equating equation, I, and 2. Sx p dx cos equals xgxhx p/4x d2. Thanks for watching. For now, please subscribe, like, share and do not forget to press bell icon.